Well, it's time for today's most asked about questions. So here they are for today. The first one comes from the warm-ups from today, and you have your warm-up quiz tomorrow. And you see that you're asked to take the secant of the inverse cosine. Anytime we have an inverse, we're looking for an angle, theta. So you should be thinking, okay, where is cosecant equal to -2? Well, even if you don't know, you could draw a triangle. And cosecant actually would be negative in the fourth quadrant. So let's draw a fourth quadrant triangle. That would be better. Here's your angle, and the cosecant is the reciprocal of sine. And so the hypotenuse would be 2, and the opposite would be -1, and that would make this side 3. So if you're asked to find the secant, you would be doing, did I do that right? 4 minus 1. Oh, this would be the square root of 3. That's better. So the secant of this would be the hypotenuse over the opposite, or it would be 2 square roots of 3 over 3. Another way you could have thought of this is asking also for the inverse sine of the reciprocal of -2, which would be -1/2. I'm sorry, I don't know why I keep getting all that stuff. All right, so there's your final answer for the warm-up. Second, you're asked to write the following as a sum or a difference. These are given to you as a product. This is a product, this is a product. So you're going to use the product to sum formulas because, oh, good Lord, go away, cancel. Okay, hopefully that'll work. Because this is a product and they want you to write it as a sum. So I see sine times sine. Oh, this is a disaster. Go away. So we're going to look for sine times sine over here, and this is the formula that we're going to use. So this is 1/2 cosine of u. This is your u, this is your v. So u minus v. And then we have minus the cosine of u plus v. And now we got to clean all that up. So we have 1/2 on the outside, x minus x, those are gone. And this is y minus y, so that would be 2y. So this is the cosine of 2y minus, here we're adding, so x plus x is 2x, and y minus y, those would be gone. So this is minus the cosine of 2x, and that's how you would write that as a sum or a difference. Boy, it took a lot of room for that first one. Let's erase this and let's start the second one now. The second one, number 4, again, this is a product. I see cosine times sine, so I'm going to look over here. Here's the one for cosine times sine. So that formula is 1/2 the sine. Again, this is your u and this is your v. So theta minus pi, and let's see, it's plus v, so plus theta plus pi. Then we have minus the sine of u, which is theta minus pi, minus v, which is theta plus pi. Okay, so now we got to clean this all up. And I have theta plus theta, which is 2 theta, and the pi's are going to cancel. So this is sine of 2 theta. And over here, I have a theta minus theta. Those are going to cancel. And this is a minus 2 pi. So this is minus the sine of 2 pi, negative 2 pi. And we have a 1/2 out in front. All right, the sine of 2 theta we can't do anything with. But we know that the sine of a negative is really equal to negative sine of 2 pi. Sorry for my dog barking at another dog. Wrigley. So these two negatives are going to become a positive. Isn't that great having her in the background? And I'm not sure if in my notes I put in here that the sine of 2 theta is equal to 0 or not, but you could simplify this to 1/2 sine of 2 theta. Yes, excuse the barking dog. So sorry about that. Next, find all solutions to the equation. Okay, in order to do number 11, you're going to need to use the sum to product formulas. So we have sine minus sine here, this formula, and that's what I'm going to use to get rid of this denominator. So we're going to use this formula here and simplify this. So on top, we have the cosine of 2x, and on the bottom, oh sugars, why did that all move? Go back, go back. Can we go back? This is a disaster video. I apologize, guys. This is nuts. First the barking dog. Okay, there, my screen went back. All right, there we go. Divided by, and now I'm going to be using this identity right here. So this is your u, and this is your v, and that would be 2 times the cosine of u plus v divided by 2 times the sine of u minus v. Oops, I'm not writing v. I should be writing x divided by 2. And we still have a minus 1 equals 0 on this. So down here, we need to clean this up. This is 4x divided by 2, or 2x. This is 2x divided by 2, or x. So now we have the cosine of 2x over 2 cosine of 2x times the sine of x. And this minus 1 can really just go over here. So that equals 1. Oh, look, some things cancel. This and this is the same thing. So this is going to divide out and give you 1. That's kind of nice. And so now what we have is 1 over 2 sine of x equals 1. And I could cross multiply or multiply both sides by our denominator. So coming up here, now I have 2 sine of x equals 1. And, oh Lord, go back. Okay, here we go. So the sine of x equals 1/2. And now we're figuring out where sine of x equals 1/2. And that's pi over 6 and 5 pi over 6. Okay, shoo, got through that one. Number 12, find all solutions to this one from 0 to 2 pi. Again, we're going to have to use another sum to product formula. If I look at this, I have a difference, and the two differences are with signs. So this is the formula that I'm going to use right now. And actually, before I even use that, I'm going to do some FOIL or factoring. This is the difference of two squares. So I'm going to factor this to the sine of 3x minus the sine of x times the sine of 3x plus the sine of x. Now I'm going to use this identity for both of these and make it look a little bit better. So this is going to turn into 2 times the cosine. This is my u, this is my v. So it's u plus v, which is x, divided by 2, times the sine, sine of u minus v divided by 2. So that's that first part here, our first set of parentheses. Then, second set of parentheses, we have 2 cosine, actually I'm going to use this one here, 2 sine of u, which is 3x, plus v, which is x, divided by 2, times the cosine of u minus v divided by 2. And this all equals 0. So let's clean this up. This is 2 cosine of 4x divided by 2, which is 2x, times the sine of 2x divided by 2, which is x. That's all in one set of parentheses. Then over here I have 2 sine of 4x divided by 2, which is 2x, times the cosine of 3 minus x, which is 2x divided by 2, which is x. And this all equals 0. Okay, what's going on here is you have a whole bunch of multiplication. This is multiplication, this is multiplication, this is multiplication, this is multiplication, this and this. This is all factors. So you have all these factors that you could set equal to 0. Well, when you set 2 equal to 0, you're not getting anything to solve for it. But you got the cosine of 2x equals 0. You got the sine of x equals 0. you got the sine of 2x equals 0 and the cosine of x equals 0. The easiest ones, of course, are where sine and cosine are 0. Sine is equal to 0 at 0 and pi. Cosine is equal to 0 at pi over 2 and 3 pi over 2. These are our double angles, so we got to solve for x and then we got to divide by 2. So if you solve for 2x, where cosine is equal to 0 is pi over 2 plus pi n. Then when you go and you divide this by 2, you get x equals pi over 4 plus pi over 2n. So when you go and you put all of your numbers in for n, or you're going to start with 0, you're going to get pi over 4. And then if you put a 1 in here, you're going to get pi over 4 plus pi over 2, so that's going to give us 3 pi over 4. And then if you put a 2 in here, you would get 5 pi over 4. And if you put a 3 in here, you would get 7 pi over 4. So that's where those numbers are coming from. Over here, solving for where 2x is going to have the sine equal 0. Well, sine equals 0 at 0 and pi, so that would be pi n. So if I divide by 2, we get x equals pi over 2n. Well, if I put 0 in there for n, I get 0. We already have it somewhere. If I put 1 in, we get pi over 2. I already have that somewhere. If I put 2 in, I get pi. I already got that somewhere. And if I put 3 in, I get 3 pi over 2. So these are just repeats. So it's these answers, these answers, these answers. Or these and these, whichever way you want to look at it. All right, I'm going to do 14, power reducing formula. And with this power reducing formula, the idea is they want you to get it so it's written so you don't have any powers higher than a power of 1 first degree. This has a power of 2 in it. So the tangent squared of u is basically this formula. There's really not anything to do here. The only thing is that you have to be worried about what u is. Our u is 4x. So when we go and we use the formula 1 minus the cosine of 2u divided by 1 plus the cosine of 2u, our u is not u, it's 4x. So that's how I came up with my answer of 1 minus the cosine of 8x over 1 plus the cosine of 8x. And this is really important for next year taking integrals of trig functions. You can't take the integral of a trig function if it has a degree higher than 1, which is where this one comes from. We don't have a way of getting rid of this, but we have the power reducing formula, so you have to manipulate it using the power reducing formulas. So this cosine to the 4th, we're going to turn into cosine squared of 2x times the cosine squared of 2x. And we got a cosine squared of u formula right here. Our u is 2x. So when we go and we use this formula and we turn it into 1 plus the cosine of 2u divided by 2, I'm not going to put u in there. I'm putting in 2x. And the other one's going to be a repeat of the same thing. 1 plus the cosine of 2u, and instead of u, we're putting in 2x. So basically what I have right now is 1 plus the cosine of 4x divided by 2, and 1 plus the cosine of 4x divided by 2. Okay, we're multiplying fractions. So if we multiply, we get 1 plus 2 cosine of 4x plus cosine squared of 4x, all divided by 4. This would be so good. We would be done if it wasn't for this guy right here. He messed us up because we got squared back into the problem. So we got to go use the same power reducing formulas that we just used. And instead of this being here, u, we got to remember that it's 4x. So when we use the formula of 1 plus the cosine of 2u divided by 2, it's not u, it's 4x. So when I go to substitute it in here, I'm going to use 8x. Watch how this works. 1 plus 2 cosine of 4x plus, in here, I'm going to put in 1 plus the cosine of 8x divided by 2, and this whole thing's going to be divided by 4. Now you need a common denominator. Your common denominator is 2, So this guy's got to go over 2, this guy's got to go over 2, and because of that, we got to change these numbers. So now what we have is 2